Moving on to our next section, we are on to section 3, and we're dealing with rotations. Okay, so rotations. Okay, so rotations, to know if we have a rotation, we need a point in which we're rotating from, and we need how far something is being rotated. Okay, so anytime we're talking about, okay, we have a rotation here, we need to know the point and how far it's being rotated, kind of the angle, either in degrees or radians. Um, and then once we know that, we're able to either create the image or go back and find the pre-image. Okay. Anytime we're dealing with a rotation, we're always considering opening it counterclockwise, um, unless it's stated otherwise. So unless it's stated that it's opening clockwise, we assume we're doing counterclockwise, and that's kind of true with all with math. If you think of like a coordinate plane, okay, if you think of coordinate planes, you have your XY axis. If this is the first quadrant, where's your second quadrant? Well, it goes counterclockwise. Here's your second quadrant, here's your third, and here's your fourth. Okay, and so it goes in a counterclockwise manner. Same thing when we talk about angles and angles and degrees and all that stuff. In trig, we deal with it opening in a counterclockwise motion. Okay, so kind of in math, we always deal with a counterclockwise motion, which is the opposite direction of a clock. Okay, so if we wanted to do something that was a rotation, now here's what we're going to do. So when you have an object, you know how far you want to rotate it and the point of rotation. Okay, this is what you're going to do your rotation. You can do it by hand. All you need really is a protractor and a straight edge. What you're going to do is you're going to pick one of the points to start. Doesn't matter which one, but you just need one of them. So I'm going to start with this one, the one that's closest. I am going to draw a line from that point to the point of rotation. Okay. Once I've drawn that, which you could extend it longer if you needed this way. Okay. If you need to extend it longer that way, you can. What you're going to do now is that you're going to find a 60-degree angle. Okay. You're going to measure this length, and you're going to draw the same length over here. So if this was A, this is now A prime. You do the same thing with the next point. So let's go with this point here. So drawing it to there, I open it about 60 degrees, and then I draw the same length that I drew there. Okay, that's probably a little bit longer. Okay, if this is point C, this is now C prime. Let me do it again. Let's do it in orange now. So I do it in orange. Come on. Okay, so I do it in orange. I open up a 60-degree angle, and then I draw the same length, which if this is, let's say, B, this is now B prime. And then you do it with the last point. Okay, so our last point, which we'll do in purple. So draw there, 60 degrees, about there. Let's say this is D, this is D prime. And then all you have to do, so again, this is a very rough drawing that I have. I probably should have opened this up more. Hold on. I probably should have opened this up more. Probably closer to there. So this could be D prime. So now that we have all our points and everything, we can take our points, we connect them, and we have our image being rotated about 60 degrees. And again, this is a very rough sketch. It's not perfect, but it's close enough. So you measure out the length from one point to the point of rotation, measure that distance, draw a 60-degree angle of the rotation, draw that same length, and that's your new point. And you do it for all the points for it. Okay, points of rotation. Okay, so in, let's say, this pentagon, we have multiple different points of rotation and how far we could spin it. So every point on the outside technically is a point of rotation, because if we rotate it 360 degrees from it, we get back to the original. And usually we don't want to mention those where we have it rotate 360 and it's back at the original, because obviously it's the same. So we want to know other ones. And what we can do is we can take it from the center also, and we go, okay, I want it rotated, let's see here, each one on the inside is what, 72 degrees. I want to rotate it 144 degrees. So if I rotate it 144 degrees, that means that point A has gone 72, 144. So that means A is now at D, D is at B, B is at E, and E is at C, and C is at A. Okay, they've been rotated twice. If I want to rotate it only 72 degrees, it would only move one spot. So the point of rotation, kind of the center, in this case Z, I can rotate it a certain degree, and it's going to end up somewhere else. Okay. All right, so example of where you would see these rotations. A Ferris wheel is the easiest one, because a Ferris wheel, as it moves around, so you have these points, or you have this basket that you're kind of sitting in, and then as it moves around, you're moving X number of degrees. And it's still the same as it moves around, because it's still symmetrical all the way through. Okay. All right, so here's your homework from this section. Fairly simple, fairly straightforward, deals with rotations. Try your best if you have to do a rotation for those.